Hello, we are now starting section 3. So sections that we've covered already, quite a bit already. The sections that we've covered already, we did slope, finding the rise and the run. We talked about mx plus b, where m was the rate and b was the value that you only paid once or that you started with. And now we are going to be evaluating. Now, when we evaluate, we start plugging numbers into a function. So everything in this section is going to be about plugging numbers into a function. Problem number 1 says, which of the above graphs represents the graph of the function 10 times x minus 3 times y equals 15? And I have a number of graphs here that I'm going to pick from, but I'm going to drag those off to the side for right now because I've got a lot of calculations to do. So here I go. When one is calculating the intercepts, you need to figure out where x is equal to 0, and then at the end that's going to give you the y-intercept, and then you also need to figure out where is y going to be equal to 0, and that's going to give you the x-intercept. And those are the two values that I'm going to plug into this function and figure out what the other value is. So I'm going to try to make a straighter line here. So this should help out. Yeah, that's better. Okay, so the reason why we use this form here, which is a different looking form than we're used to seeing things like y equals 3x minus 2, and it's very easy to put x equal to 0, which makes that term go away, and you get y equals 2. That is, the intercept here is, of course, negative 2. So we're used to seeing functions in this form, which was slope-intercept form, because it has a slope and an intercept. But for problems that we're going to be doing like this, it's actually easier to use this other form. This second form is called standard form, and it is useful for when you are trying to find the two function intercepts. All right, so I've got two function intercepts. I'm going to put x equals 0 here, and then at the end I'm going to figure out what y is equal to, and then the other side I'm going to do the same thing for y. So I'm going to take 10 times x minus 3 times y equals 15. And in that function, one of those things I can evaluate, that is, I can replace with 0. So I know that x is equal to 0, and so I can take the x and I can replace it with the number 0, because x is equal to 0. Now, 10 times 0 is, of course, just 0 minus 3y equals 15. But the whole point of doing standard form is that you can put x equals to 0, and the first term you know is just going to go away altogether. So it's as though you could just cover that up, and you know that you're going to be left with negative 3y. In other words, as soon as I see this 10 times 0 here, I know that I can just go ahead and write, not writing the 0, don't have to write the 0, I can just go drop straight down and write negative 3y equals 15. That's everything that's going to be left in this equation. Now, this is negative 3 times y equals 15. Negative 3 times y, and the opposite of times is divide. So I know I have to divide both sides, and I'm going to divide both sides by negative 3. Negative 3. Why? Because negative 3 divided by negative 3, that's what gives me positive 1. Okay, so I need to cancel the times negative 3 with divide by negative 3. All right, and I'm going to go ahead and cancel those out. They're opposites. So I'm left with y. The line gives me the equal sign, and I have 15 divided by negative 3. So another way of writing this, 15 divided by negative 3. That's what the fraction means, is divided by. So I have 15 divided by negative 3, which is 5. And then because there's a negative here, just one negative makes a negative. So I'm going to put a box around my answer. My first intercept, and I need to put it over here so that I have room for it. My first intercept was x equals 0 and y was negative 5. So when x was 0, y was negative 5. Okay? And now I'm ready to do the same thing with y is equal to 0. So I've got the equation starting 10x minus 3y equals negative 15, or equals just 15. 10x minus 3y equals 15. And in this problem, y is equal to 0, so I can replace the y with the number 0. And that's what I'm doing here. I'm evaluating, which means replace the letter with a number. Standard form is the easy form to use for finding intercepts because if y is 0, that means this term just goes away. It's now 0. And I know that I'm going to only be left with the 10 and the x. 10 times x equals 15. Okay, so this is 10 times x equals 15, and the opposite of times is divided by. So divide both sides here by 10 and cancel your opposites. X is equal to 15 over 10, but because there's a common factor of 5, I can divide both the numerator and the denominator by that 5. 15 divided by 5 is 3, and 10 divided by 5 is 2. Okay, so I've now solved for x. What are the steps for finding the intercepts? Well, you set y equals 0, you evaluate, that means cancel the y term. You do some algebra and you solve it for x. And you have to do that for both because you have both an x and a y intercept. So what do we find here? We found when y was 0, x was 3 over 2. And I'm about to erase all this stuff, so if you need to copy this down, then pause it. Okay, so here we go. You'll notice that these problems are getting longer and longer. I still have students that argue that they can answer this stuff in their head, but I really don't think you can. You need to be organized and you need to go one step at a time. Okay, so here's our graphs again. We're looking for the first value to be 0, negative 5. So 0 in the x sense and negative 5 in the y sense is going to be right there. And then the other one is 3 halves. Now 3 halves is otherwise known as 1 1/2, or otherwise known as 1.5. It's a number that's between 1 and 2. So when y is 0, that means on the up and down sense I'm at 0. Then I go over to 1 1/2, which is right there between 1 and 2. And then I can connect those two dots with a line. So let's see how close I can get here. Okay, something like that. Alright, so we're looking for the line that looks like this, and it should be pretty clear at this point which one we're looking for. The correct answer here was the top right. That was the only one. Really, all you had to do is figure out that one of the intercepts was negative 5, and you would have been off to the races. It's the only one that's right. Okay, so moving on to... that was such a long problem, I'm actually going to go ahead and start to the next video. Just to summarize what we're covering, remember that in this unit, in this section, we're talking about evaluate. So I'm about to replace x with 6 into these two functions. So that's what I'm going to do for the next problem. And then I'm going to start replacing both x and y. So I'm going to be replacing x with 1 and replacing y with 1 and seeing which one of these works. And we need to talk about situations that are not a function. So is it possible to put 5 into a function and get two different things out? Okay, I'll cover those in the next video.